Hello guys, today we will discuss some more topics relevant to petroleum geology. Key rocks for petroleum deposition or accumulation and then migration are sedimentary rocks. Hydrocarbons deposited in these rocks, so these are very important for petroleum exploration. Sedimentary rocks fulfill three important requirements for a commercial petroleum accumulation in the subsurface. For example, source rock as shale and mudstone, those act as a source rock. Reservoir rock as sandstone and limestone. And cap rock. In cap rock, you can also add evaporites as well in addition to shale. Today we'll discuss a little about evaporites as well. A detailed study of these rocks is essential to understand the petroleum play in any area. Petroleum play at this stage, I will just explain like that. If all the components for petroleum accumulation, migration, and trapping, if exist in some area, we can say petroleum play present there. Okay. Okay, here are some you can say distribution of rocks, relative abundance of rocks at the Earth's surface, and on right side relative abundance of rocks in the Earth's crust. Let's see the sandstone in yellow. As you can see in the Earth's crust, there are about 7.9% sedimentary rocks, and we are more interested to study those rocks. And if we further subdivided this percentage, you can see here we have sandstone and limestone and shale. Those mostly exist at the Earth's surface. So these three rocks are also important for petroleum accumulation, migration, or for petroleum play. Shale, sandstone, and limestone are important. Okay, here is the production from sedimentary reservoir. This data was collected from, you can say, from the globe, from different countries, and then plotted. And as you can see, the majority of the reservoirs in the world, those are carbonate plus sandstone as well, from where we world is getting production. So you can feel the importance of these particular rocks, sandstone and carbonate, and these are sedimentary rocks. And there are also some other rocks as well where minor quantity of production is also exist. Okay, here is an overview about deposition of sedimentary rock, particularly in the marine environment. And if the source is continental, or it can be igneous rock from where these are eroded, and then they move towards the river, sea, ocean, and settle, just like the limestone settle at the more depth compared to shale, and then at the top there is the sand. Okay. Today we will learn about these sediments, their properties, and how we can assess these depositional environment. You can realize from this figure, before starting any discussion about petroleum accumulation or petroleum generation in a source rock, or anything about petroleum within the rocks, first of all you have to study the petrology of rocks. Petrology is the study of rocks. You have to look in detail. So we will, in coming slides, we will see and try to understand the petrology and morphology of these sedimentary rocks. Okay, detailed study of sedimentary rocks actually required to study these three subcategories like sedimentary petrology, sedimentary structures, and the third deposition environment. These are the important, you can also say, steps to interpret a sedimentary rock. Okay, sedimentary petrology. There are two types of sedimentary rocks, clastic and non-clastic. In clastic, there are sandstone, shale, siltstone, and in non-clastic, these are limestone, dolomite, and evaporites. Classic rocks defined as those rocks which formed from pre-existing rocks whose constituents were transported by some mechanism like wind, water, or glacial ice to the area of deposition. And the carbonate rocks or non-clastic rocks have complicated and varied depositional environment or deposition patterns and are subject to extensive post-deposition alteration. Alteration means their composition, their texture, their morphology also varied after deposition as well for carbonate rocks. Here on the left side, there are some examples. On top there are different sandstone and below an example of limestone. Okay, now we will see how these rocks are important for petroleum. So these are very important slides. Sandstones are classic sedimentary rocks composed of mainly sand-sized particles or grains set in a matrix of silt or clay and more or less firmly united by a cementing material. The sand particles usually consist of quartz, and the term sandstone, when used without qualification, indicates a rock containing about 85 to 90% quartz. If it is a pure sandstone, you can say more than 80% there is a quartz. And it also contains some cementing agent that we can say keep the particle in contact, and those cementing agents are sealed, set in a mattress of silt or clay, and also sometimes limestone also sometimes acts as a calcium carbonates as a cement agent in sandstone rock. Okay, next is shale or shales. Shale is a type of detrital sedimentary rock formed by the consolidation of fine-grained material including clay, mud, and silt, and have a layered or stratified structure parallel to bedding. Shales are typically porous and contain hydrocarbon but generally exhibit no permeability, or you can say very low or very minimum permeability. Therefore, they typically do not form reservoirs but do make excellent cap rocks. If a shale is fractured, it would have the potential to be a reservoir. Okay, in last lecture, we also, I think, discussed a little about shale, where I think I mentioned it contained very low porosity, and I will add in those notes that some shale also have good porosity as well. So there is a possibility that shales are good porous, but permeability is very low or there is no permeability. You have to fracture it to create permeability. So that's also another topic of unconventional reservoirs where we see in detail the properties of shales. So at this stage, you can understand it that porosity may be present in shale, but there are very minimum or no permeability. Okay, limestones are sedimentary rocks consisting chiefly of the mineral calcite, with or without magnesium carbonate. Limestone are the most important and widely distributed of the carbonate rocks. Yeah, in carbonate rocks, both limestone, dolomite, and evaporites, they are considered as carbonate rocks, but they have different chemical composition. Just like dolomite is a common rock forming mineral with the formula this, magnesium is going to be added in this CaCO3. A sedimentary rock will be named dolomite if that rock is composed of more than 90% mineral dolomite and less than 10% mineral calcite. You will say it is a dolomite. Okay, evaporites do not form reservoirs like limestone and sandstone, but are very important to petroleum exploration because they make excellent cap rocks and generate traps. So, evaporite is also, you can say, important for petroleum industry. So the term evaporite is used for all deposits such as salt deposits that are composed of mineral that precipitated from saline solution concentrated by evaporation. On evaporation, the general sequence of precipitation is calcite, gisement, halide, and finally bitter salt. So, from petroleum prospectivity, evaporite make excellent cap rocks because they are impermeable and unlike lithified shale, they deform plastically, not by fracturing. Okay, now we will see how different properties of these rocks can be studied and how these properties can be used to identify a petroleum reservoir, petroleum source rock, or existence of petroleum in a particular area. So, if we focus on grain, then there are different properties of grain that should be studied. For example, grain size, grain shape, their sphericity, contacts, texture, fabric. All these features guide in the prediction of depositional environment of a particular lithology or geological formation. Actually, this deposition environment actually guide us that where petroleum had been deposited in the past. Okay, to identify a particular area where petroleum can be found, we have to study deposition environment because petroleum deposited in a particular deposition environment or stored in a particular deposition environment, even in migrated in a particular deposition environment. So this you can say deposition environment is very important for petroleum exploration. Okay, first of all, grain size. As you can see, here is the range of grain sizes those exist in nature from clay to boulders. Yeah, for clay there is minimum size, and for boulder there is very large size. And similarly, in between you can see sand, silt, mud. They are from half to 1 by 1 to 8 mm. And you can just keep in mind the particular range for these rocks which are important for petroleum perspective. It's like sand, silt, mud. Okay. After grain size, the other important parameter is grain shape, and this shape can be observed under microscope or even some rocks you can observe with your hand lens as well. Here are different terminology for their roundness, like high severity or low severity. If you move this in horizontal, the high sphericity exists in these grains, and here low sphericity exists. Similarly, other terminology, angular, subangular, or well-rounded. To predict the origin, history, and internal lattice structure of the particles, these properties are very important. Okay, the other property is the grain contact. These features help to assess imposed stresses and particle dissolution due to the overburden or from deformation. As you can observe in this diagram, there are different type of grain contact. Just like in A, this is a point contact, we will say, and in B, this is long contact, and in C, concavo-convex contact, and then saturated contact in part D. And also some more examples are here, which are floating grains and which are in contact. These contacts, as I mentioned earlier, will give some assessment of stresses, what type of stress is imposed on these grains, and how the particle dissolution happening in the past. So this information is also important ultimately to define a particular deposition environment for these type of rock. The action or process of dissolving or being dissolved is called dissolution, or you can uh, define dissolution like this as well to understand this mechanism. Okay, next important step is how to plot these data, how you can plot the composition in a particular rock. And for that, ternary plot or triangular diagram is very important to understand. First of all, let's observe that at the top it is clay, it is on the left corner sand, and on the right corner silt, and their percentage is varied relatively. Let's suppose if I have a sample and I measure the different percentages of sediments, those are deposited in that particular rock, and I fall somewhere here, which means this is clay area. In the sample I have in my hand, that will be clay. If I analyze a sample and that falls somewhere here, then I can assess what type of lithology that is. And for reading these sides, at this point, sand is 100%, but clay is 0%. Similarly, silt is 0%. If I read at this point, at this clay, here at this point, clay is 100%, sand is 0%, silt is 0%. Okay. If I move downward from clay towards silt, silt will be increased. As you can see, it's going to increase, and if I reach here, it will be read as 100% silt. So, whatever your analysis, you can put your data on this diagram and can assess where your rock sample fall. Either it is clay, either it is sandy, or something else. So it is very important, first of all, to assess based on the percentage of sand, sediment, silt, sediment, and clay, and to categorize a particular rock. Okay, here are some more examples. The colored dots, square, triangle, those are actually your observed data or the data you analyze on your samples. And when you plot your data on these diagrams, these triangular diagrams will help you to interpret the lithology of your rock sample. And as you can see, we include clay, sand, silt. That means you are analyzing sedimentary rocks. And here are the different, you can say, categorize in this diagram: silty clay, clay silt, sandy silt, and even your if rock sample is heterogeneous, lithology is varying very much, then that trend can also be observed on these diagram if it is too much heterogeneous like this as well. Okay, next important step is classification of sandstone. The matrix of a rock is the finer grained mass of material in which larger grains, crystals, or clasts are embedded. This is just imagination, you can say. You can imagine how sandstone looks alike. Okay, it is very important to understand this diagram. Let's follow my cursor. This red circle represents the quartz. Here we change a little. We replace this time with minerals. These are the, you can say, dominant minerals in sandstone. Quartz, feldspar, and other rock fragments. You can say other minerals as well here. And if the quartz is 100% in your rock sample or in your sandstone sample, your data will fall here. If quartz is less, feldspar high, your data will fall here. So with the variation of these minerals, quartz, feldspar, and other minerals, the sandstone type is also going to be changed. And for that, there is a specific terminology. For example, arcosic arenite, or you can say arcosic sandstone, lithic arenite, lithic sandstone, or sublithic arenite. Similarly, if you move from towards uh, to, towards right side, here there are arenites. Arenites actually represent the greens, and mostly we observe in the field some of the sandstone they only contain grains. There is no matrix there. If there is a matrix as well, more than 15% matrix, then you can also categorize those sandstones towards wax as well. But the majority of the sandstones actually fall in this zone in arenites, and their composition also vary, and based on the variation in their composition, some specific uh, terminology is introduced just to recognize those type of sandstone. As you move away, as you can see here, there is a mudstone. You're going to mm, move and going to towards the mudstone and clay at a particular size of grain because these are more finer than sandstone. So these are not tough diagrams. These are very easy to understand. Just you have some basic ideas how to read these diagram and what does it means by the variation of these minerals. And a lot of literature is available for these classification of sandstone. Okay, here is very quick view of Arcosic arenite or a type of sandstone. And on right side there is a grey wag rock, a type of sandstone. As you can observe on left side, these are looks like greens, and here is a wag. So these type of, you can say, variations that actually required to classify the sandstone. Okay, here are some, you can say, more information on mud rocks. As you can see, the important mud rocks for petroleum industry, those are consolidated like shale, mudstone, and even sometimes silt. See how silt impact our reservoir rocks and others. Okay, yeah, the main composition is from silt and clay. Okay, next is the non-classic petrology. Non-classic mean carbonate rocks or limestone, dolomite, evaporites. As you can see here, you can observe some fossil structures as well. And as we move from left to right, there is also some variation in your composition, like lime mud matrix. It's like a mud, but it's lime. And then it's here is some calcite cement as the color change. And with this movement, their properties are also going to be changed, due to which different terminologies have been introduced. And this type of classification is called folk classification. Folk was a scientist who introduced these classification for limestone. All the limestone are not the same. They have different texture, different morphology, different properties. So specific terminology should be used for each type of limestone. Similarly, percent of allochems, as you can say, if it is 0 to 1%, up to 50%, you will use right matrix terminology. Similarly, if they fall in this category, sorting poor, sorting good, you will use this terminology. The important thing about these classification that you need to understand the variation or variability in your in a single rock like limestone. As you can observe in this diagram, the limestone is not a single calcite mineral. Yeah, its nature is going to change, its texture is going to change. It can be lime mud, not calcite, but it can be calcite as well with some other features. So the purpose of these type of slide to get some realization regarding the variation in a particular rock. Okay, here is another classification of limestone. This is called Dunham limestone classification. As you can see, here are also some more terminologies. And don't worry about these terminology and don't try to memorize so quickly these terminology. Actually, these features require a number of years to learn about these and to memorize these features. So at this stage, as you are studying at bachelor level and you are studying introduction to petroleum geology, so you can just keep in mind that limestones are of different types and their texture, features, morphologies are going to be varied. And there are different types of classification as well. Different scientists classify the limestone in a little different way. So these are some observations those you should uh, got from these slides at this stage. And in later on, hopefully, if you focus on this subject for your project or some other assignments, then you can see in detail for a particular limestone. Just like if you got some packstone sample, then you can see how much mud is there. It's more than 10%, either is grain spotted or mud spotted. So if you focus on a particular type of limestone, then you can go for in-depth knowledge. Otherwise, you have to get some generalized view of these type of limestone. Okay, here is ternary or triangular diagram for limestone. As you can see, this time we put dolomite here, calcite here, and some impurity here. Similar like sandstone we classify. Some different terminologies as well. Dolomitic limestone, calcareous dolomite. These vary with the variation in percentages of these calcite dolomite. Okay, here are some examples of principal sedimentary evaporites. As we discussed earlier, evaporites are also important for petroleum industry. They can act as a cap rock as well. Okay, here are some chemical formulas for chlorides and sulfates, and here are their species. Okay, after sedimentary petrology, the next important features that need to be studied before starting petroleum exploration, uh, that is the sedimentary structures. There, how sedimentary structures are going to vary in your study area, and these structures will help you to understand the deposition environment. Okay, next important sedimentary structures. Let's see. Okay, sorry. These are used. Okay, sedimentary structures. These are used to understand the changes experienced by sediments in a particular deposition environment. Ultimately, impact the interpretation of deposition environment and deposition of petroleum. Okay, here are different types of sedimentary structures: internal structures, biogenic structures relevant to fossils, upper bedding planes, non-biogenic, low bedding planes. Okay, let's see some details of these structures. Okay, here are some parallel bedding structures, and what we can interpret from these figures, these diagrams. Parallel bedding surfaces indicate that there is a pause in normal sedimentation process. These surfaces, these parallel bedding, you can say. Similarly, uniform lithology between these surfaces indicating a constant source and transport of sediment. This is, you can say, a first observation when you will observe these features in field. You can interpret that what was happened in the past and how these beddings form. Okay, here is a typical example from the field. On the right side, you can see current beddings, and some white lines were drawn on those beddings. And these beddings shows, this figure shows movement of a wave of sand. And different terminologies for these type of features. For example, cross bedding, ripple bedding, diagonal bedding, false bedding. And if you are interested to look into detail into those, you can go on Google, search these terminologies. You can see actual field images about these beddings. Okay, here is an example of graded bedding, finer sediments in upward direction, and mostly the coarser at the bottom. Typically at the right side, this view you can observe coarser at the bottom and finer at the upper side. And these type of features are very helpful to identify a depositional environment. And that depositional environment will guide us either there is a possibility of petroleum deposition or petroleum accumulation or petroleum generation in this area or not. So you have to identify these features in field, then have to plot on a piece of paper for interpretation. Similarly, some other examples, these were also observed in the field, then some 3D models were developed for those cross bedding, wavy cross bedding or planar cross beddings. Okay, graded bedding, also called Boma cycle. Boma was a scientist who actually was working on turbidite, and he developed um, these type of sequences on your right side. First of all, the loss unit is definitely graded and is usually the thickest part of the sequence, like this graded bedding. The second section commonly displays ripple cross lamination, like air laminations. Then the third unit is composed of indistinctly laminated sandy or silty pellitic sediments. Similarly, a poorly defined and often not recognizable unit with horizontal lamination somewhere here, and upper is mostly derived from mudstone or petrology shape. And this particular sequence that Boma observed in turbidite that actually also uh, helps a lot in understanding the deposition environment and to assess the detailed history of these sediments, how these were deposited, what type of environment they observed in the past. So these type of, you can say, lithological log or vertical information of a particular area is very important and is necessary to develop before going for petroleum exploration. Okay, here is some correlation of similar features. If you have studied three sections, these can be on outcrop or these can be the drilled wells or drilled boreholes, and then you have to correlate those features so that you can develop a 1D geological model so that you can learn how literally these features are going to be varied. Okay, here is another example how these information can be used effectively, and it is also your lab one. We also call it Wells correlation to develop one geological model. If you have multiple boreholes, you have to identify the similar lithologies, then correlate, then at the end, geological model will develop that will help you to understand the deposition in a particular area. So hopefully you are doing well with CorelDRAW software and hopefully you have learned something from there and now you can easily develop these type of 1D geological model. Okay, I will stop here and expect that let's listen this lecture and see how much you can absorb and how much you can understand. And in part 2, I will explain about depositional environment. And this is the end of lecture 2, part A. Thank you and bye.